Hey everyone, my name is Akash and I welcome you all to Protocol Bytes. In this video, we are going to talk about Address Resolution Protocol. Yes, in short, ARP. So without any further ado, let's get started and just jump right onto my screen. So there we go, Address Resolution Protocol, in short, also called as ARP. So what is ARP? ARP helps you to map your MAC addresses to your IP addresses in a simple network. So in this video, we are going to focus on a same subnet network only via a switch. Okay, I have a switched network over here, um, which has six customer equipments, or even you can call this as laptops, which are connected via a switch, all in the same subnet. So if you see over here, each device has its own IP address and MAC address attached to it. Uh, where you see C1 as 100.0.0.1, C2 as 2, and so on up to C6. Switch is configured with the same VLANs on all the ports connected. So what we'll do is on C1, first things first, C1 wants to talk to C6, so whose IP is 100.0.0.6. So now to achieve that, what C1 will do is C1 will check its own ARP table whether it has the entry for this particular device. So since we have just started it, it doesn't have it. So now what C1 will do it will generate a ARP request to get information about the MAC address of C6. Why? Because that's the only thing which it doesn't have. So let's write it down what C1 has already. C1 has a source IP that is 100.0.1. It has the destination IP also. It has to reach 100.0.0.6. Okay. It has the source MAC. Source MAC is AA. MAC address is ideally 6 octet, so it will be 6 times and colon in between, but for representation purpose I have taken just AA. Destination MAC is unknown, that we have to learn. Okay, so now whenever there is a scenario when you have to learn a destination MAC, in this case ARP comes into picture. So what C1 will do is it will generate an ARP request. So now C1 has generated an ARP request with all these parameters: source IP, destination IP, source MAC as self, and destination MAC as all F. Now this ARP request reaches switch. Switch, since it is a new device, recently termed up, it will be empty at first. So first thing the switch will do is it will fill up its MAC table. Okay, MAC table, basically it has the entries of the MAC and the associated interface that it has received. So in this case, it will open up the layer 2 header of this ARP request. It will see that okay, I have got AA coming from CE1. C1, it will be the interface over here. I have not written, so let's consider C1's facing interface. The next thing it will do it, since the destination MAC was all F, it will generate duplicate copies of it, or just consider it to broadcast it to all the other ports which are in the same domain. So it will replicate it to all the ports. Okay, now let's see what C2 does about it. So as soon as C2 receives this ARP request, so first thing it will update its own ARP table. Okay, so what it will do is it will store information, source information of AA received from, and also the IP information, because it is a device, it has it's an L3 device, it has an ARP table in it. So now and then when it tries to open the further headers, that is the IP, it will see that okay, the source IP is this, destination IP is not his own, so it will reject this frame. Okay, it will do nothing. Similarly, C3, it will fill up its ARP table, AA information 100.0.0.1, and then it will do nothing because it is the packet is not for him. Same thing, C4 will update its ARP table, store the source information of C1 and discard it. C5 will do the same, store the source information and discard the packet. C6 will do something else. It will generate in the ARP table. First, it will store the information Okay, and when it opens the layer 3 headers, it will see that okay, it is for me. So I'll have to generate a ARP reply and provide this information to the sender. Okay, so now in this case, C1 will generate a ARP reply packet. This ARP reply packet, what it will contain? Source IP will be now his own 100.0.0.6. DIP will be of the sender who has sent the ARP request. Source MAC will be in this case AF, its own self MAC. The destination MAC, since now it has populated its ARP table, it will pick it up from this. In this case, it will be AA and send this on the wire. As soon as switch receives this ARP reply packet, it has received nothing from other devices since they have discarded the frames. In this case, it received from C. So first thing it will do is it will store the source information and populate its MAC table. So now it says that okay, I have this MAC AF received from C6. These are the interfaces, okay, not the device. So the interfacing pointing C1 will be stored here. Further, it will, since now the destination MAC is unknown, because it has already have the information of C1, it will directly send that packet to C1. C1, as soon as it receives this, again it will do the same. It will update its own ARP table. First, it will take the source information from the packet. AF is 100.0.0.6. His own information will be there. It will open up the layer 3, okay, and then it will say, okay, it is received for me, it will accept. So now this information which was unknown previously, now it is known because of ARP request and the ARP reply that you received. Now next time when you have to send a data from C1 to C6, what it will be there? You will have a data, and now the source IP, it is known, the destination IP is known, you also know the source MAC, you also know the destination MAC, and then the frame. With all this complete information, now the packet will be sent to the switch. Switch will straight away check the destination MAC, and it has an entry now. It will directly send it to C6. So that is how ARP request helps you to get the destination MAC information in your local network. Same procedure will be followed by other devices, and if the table is already updated, it won't be broadcasted. In case if you received a broadcast stream, only in that case it will be broadcasted by switch. In case it has entry in its MAC table, it will not be broadcasted. Okay, I have a packet capture to just showcase how it looks. Okay, this is an example. Okay, it's not from the same what we just saw. So in this case, if you see, this is the ARP request which is generated. The destination is broadcast all F, and if you see, there are 6 octets. Source IP will be of C1. In our case, it was AA. Now you see the address resolution protocols. You see the protocol ID over here, and in here you see the source IP, source MAC, SMAC, source IP which was known, destination IP which was known, and the target MAC is unknown, right? So this we have to find with the help of ARP request. So you have generated an ARP request. Now for this you will get a reply. Let's see what we have. This one is received from the remote C, okay, as a reply, and you see that source IP, source MAC and the destination MAC is now known, okay, because those were the information present in the ARP request packet. You see the source sender's MAC is there, destination MAC is there. You have the sender's IP and destination. All the fields are populated now. With the help of this, C1 will now know how to reach C6. Okay. So guys, that was all for this video. I hope this session was informative and it surely added some value to you. So in next video, we'll try to cover different subnet scenario. In that case, how an ARP request flows and how you can reach from point A to point B who are in different subnet. So that's all for this video. Thanks for watching guys. I'll see you in the next video. Bye.